Alright, finally, after all the algebra review, we're ready to start geometry. We're going to start with section 1.1, points, lines, and planes. There's going to be a lot of vocabulary on this, so be patient as you go through all this information. Alright, let's start with a point. A point indicates a location. Alright, in a location, the point also has no size. Okay? So what does that mean? It means that the point can, since it's a location, it could represent my house. My house could be a point. Earth could be a point. Okay? A small pin, the top of the pin could be a point. It doesn't have a size, so it just represents a location. How to name it? We're going to use a capital letter, and as an example, we're going to use point A. So over here, we're going to draw a picture. We're just going to draw a little point and use a capital letter, and we'll use capital letter A. Alright, moving on. A line. A line is represented by a straight path that extends in two opposite directions without end and has no thickness. So, like a point that has no size, a line has no thickness. Okay, so we don't. All we know is that it goes on forever. The way we know that is by the little triangles that it has here in the line that extends forever. Okay, because it extends forever, a line contains infinitely many points. We don't know how many fit in there. It could be a few, it could be a million, it could be a billion. Remember, a point has no size, so many can fit in there. Alright, now let's look at how to name it. Option 1, we can use any 2 points on a line. So, as an example, we have these 2 points being indicated here, A and B. So the way we can name this is by using capital letter A with a B, and then we're going to draw a little symbol of a line with the little arrows. So that should be 2 little arrows, and that indicates AB. Now, the points don't matter in which way it goes. It could be AB, or you could change it the other way. It could be BA. So direction doesn't matter because it's going infinitely both ways. So you can name it AB or BA. Okay, moving on. Option 2, a lowercase letter. If you notice right over here, you've got a symbol, and it's going to use a cursive. A cursive is, well, you see what the cursive looks like, so I'm not going to get more into detail of that. So a cursive you can use, and it's going to be a lowercase letter. So in here you would say that this could be thought of as line L. Okay, so line L is another option you can use. And on this example, you could have used AB or BA or line L to indicate the line. Okay, all right, good. Let's move on to the next thing. A plane. Okay, so a plane is represented by a flat surface that extends without end and has no thickness. So, like a point has no sides, a line has no thickness, a plane also has no thickness as far as and it extends forever. A plane contains infinitely many points also. Okay. Alright, so here's a plane. Okay, it's got points A, B, and C on them. And let's start with option A of how to name it. So option 1, any 3 points on the plane is one way you can name it. So if we choose the 3 points, there are 3 points here, A, B, and C. We can call it plane A, B, and C. So we just write the word plane and then the letters A, B, and C. Is there a symbol for this? Unfortunately, no, there isn't. Okay, we have to use the word plane. There's no other option to that. Okay, the letters. Okay, it's any three points. So I could have called this plane BCA, plane CAB, plane BAC. So there's many options in which you can talk about the name to name this plane. So all you need is 3 points. Okay. And again, we're going to use capital letters for that too. All right. Option 2 is to use a and actually this is incorrect. It shouldn't be a lowercase letter. It should be a higher case letter. So let's change that. All right. So higher case letter, and in this case, it's going to be the point P. Usually point P is going to be also cursive, but I couldn't do it on this example. But all it needs to be is capitalized. So my mistake here is it is a higher case letter, so we're going to go ahead, or capital letter, so we're going to go ahead and use plane and then the capital P. Okay, so plane P is the second option of doing this. So those are the two ways in which you can name a plane. You can use capital letters A, B, C to indicate 3 points, or use the cursive or the point that is by itself, and you'll see this in the corner somewhere around the plane as plane P. Okay, now we're going to go through an example here so that you can get an idea how this works. So let's kind of break down points and break down a little bit on the lines. Alright, so let's find some points on this diagram right here. So we have point, well, we got point E, so we're just going to put point E. We can use point B. We can use point X. And we can also indicate point L. Okay, now lines. We can use, for lines, we can use line S right here. We can use the line M, the one that's going up and down, so that'll be line M. And also we can use two letters, so we can use two capital letters, EB, and then we would draw an arrow, the little line symbol showing that it's a line EB, or you can call it BE. Remember, the letters don't, which letter you use doesn't change what it is. You can use, say, BX, and so forth. Alright, now you couldn't indicate anything for the line M because it's going straight up and there's only one point. There's no other point on the line, so that means I couldn't use that. Alright, let's move on to planes. Alright, for the plane you can use plane C, and I'm talking about the capital letter you see here in the corner. So that could be an example of a plane. You can also use three letters, but you got to be careful which three letters you use, and I'll show you what I'm talking about. Alright, so E, B, L. See, that's a plane. You could see how that can be drawn out as a plane. So you could say EBL. Okay. Now, I can also use, say, and just make up a plane. So let's say I could use EXL. You get another plane right here. And you could see how this is another plane right here. You can actually visualize a plane, or draw it out in my case. So plane I'm sorry, not EBL, EXL, EXL. Alright, so that one works. Okay, here's your plane. Now, here's something you didn't know, okay? So how about plane EBX? So if you look EBX, so if I write plane EBX, okay, is that possible? Is that considered a plane? Remember, a plane is a flat surface. And it's gotta actually make a surface. And if you look at EBX, if you connect the points, it's just a straight line. So EBX does not work. That means that we cannot use those three letters. So the three letters have to actually form a plane. You have to visualize a plane. If you can't visualize a plane and all you see is these 3 points on a straight line, then it's a line. It's not going to be a plane. Okay, so here are more terms, so more vocab. Alright, let's start with collinear points. Collinear points are points that lie on the same line. So if you see this right here, you have a picture of a line and you got points A, B, and C. All 3 points are on the line, so therefore all 3 points are collinear. If there was a point that was outside the line, then that point would have been non-collinear. So say if I drew something here and I put, say, P here. Well, I would say point P is non-collinear, but points A, B, and C are collinear, meaning they're on the line. Alright, moving on. We have coplanar. So coplanar means points and lines that lie on the same plane. So if we look at this here, this picture, you have this line right here with the R, point R and Q, that is really line S right here. That line is on the plane, so therefore that is coplanar. Points Q and R are on the line, therefore they are coplanar. Point Z, that is right here in the corner, that one is on the plane, therefore that one is also coplanar. So what is not coplanar is this line that is crossing through. it's going by and it's going to be point R, so therefore line R is not coplanar. Okay, all right, so that's what coplanar means. Space, the final frontier. No, it really just means set of all possible points. So think of space, our universe. It represents everything, includes all possible points. So space is the set of all possible points, and that's its definition. Okay, so here's an example. Let's start with this example. You have this in your notes, and so let's follow along. What are two other ways to name QT? So let's go ahead and find QT. All right, QT would be, here's Q, here's T. So they're saying name two other ways to name this line QT. Well, the first thing you can do is change the letters. So just say TQ. Okay, so that's another way, one way you can name it. It's on this line, so I could use another point. I could use, say, NT. So I could use NT. Okay, I could have used line M. Okay, well, I have more than two. So there's some examples, and again, you can also switch letters around to indicate this line. What are two other ways to name plane P? So plane P. So plane P is pretty much indicating this whole area right here. And planes go infinitely forever this way, and this way, and this way. So they go all around. Okay, so name two other ways. So plane P. So for this, I could use, let's see, all we need is 3 points. So I'm going to go ahead and use this point, R, and I'll use Q and V. I can use that one right there. Okay, that is a plane, indicating this plane right here. So I'm going to go ahead and call it plane RQS. Okay, and I could have switched the letters around. It wouldn't have mattered as long as I have 3 points. Okay, let's see, another one I could use. Let's say we do point RSV. Okay, this is another one right here. So R, S, and V. That would have worked, and that shouldn't be a problem. Well, what about point R, Q, and S? Could I use plane RQS? Okay, the answer is no. Remember, it's on a straight line. It actually has to make a design. It has to make a plane itself. So this is on a straight line, so that one doesn't work. So we can't use that one. So that one's out. All right, let's move on to the next thing. Name 3 collinear points. All right, so collinear points are points that lie on the same in the same line, collinear line. So let's go ahead and use, say, this example here. So if I use this one right here, I'm going to use line L. Then the points that are collinear are R, Q, and S. So I could say R, Q, and S, and that would be for line. We could say that one's probably for line L. Okay. Well, what if I wanted to use another line? Let's say I wanted to use this line right here. Okay. So this one going up and down. So if I was going to use that one, okay, I could say that I could use points T, Q, and N. T, Q, and N, and let me put some separators there, and I forgot to do that with the other one, but that would be for, this one would be for line M. Okay, so any of those would have worked. Alright, name a point not collinear with points R, S, and V. So let's go ahead and find those points. R, where's R? Here's R, S, and V, and find points that are not coplanar to these particular 3 points. Well, here are 3 points. These 3 points make this plane, which happens to be the same as this plane right here. Okay, because remember, planes go on forever. So if this plane goes on this way forever, it goes on this way, this goes on forever. So this plane is the same as the plane that you're seeing here. So the plane goes on forever, So there's only, really you can just think of it as this being the plane. Okay, and it goes on forever. So there's only 2 points you could use. That means the only 2 points you can use are points T and points N. So you could have used either point T or N. Okay, so now let's go on to even more vocabulary here. A segment. A segment is part of a line that consists of 2 endpoints and all the points in between them. Okay, just to make it simple, think of a segment as it's just something that starts at a point and ends at a point. That's a segment. So it doesn't go on forever. It actually stops and starts, starts and stops. So naming it. Okay, to name a segment by its by its 2 endpoints. So you would use the capitals A and B, but then you would use just a line like this with no arrows at all. Or you can again switch the letters. It doesn't matter the order of those letters. So you could have gone BA. Okay, and then draw a straight line like that. Don't show the little arrows. So it starts and ends. That's really the difference between a segment and a line. Moving on, we have a ray. A ray is kind of a mix between a segment and a line. So a ray is part of a line that consists of one endpoint and all the points on the line in one direction. So when you're looking at a ray, you're looking at, say, point A here, and on point A starts at point A, then it goes infinitely forever, but it has a point B indicating somewhere along the line that this, and then it goes on forever. So name a ray by its endpoint and another point on the ray. The endpoint must come first. So that's the important thing you need to know. So the endpoint always comes first, which means we're going to use the letter A. So so I'm just going to go ahead and show you here that this must always be first. So we're going to go ahead and start with the letter A. Then you can go ahead and show the letter B. Okay, the symbol has to be, it's going to look like a ray. So it's going to start with an endpoint and then point towards a arrow. So one end is an endpoint and the other is an arrow. And so let me do that again so you can see it. It's going to be AB, and then that would be the symbol. Okay, all right, good. Moving on. Okay, opposite rays. Opposite rays are 2 rays that share an endpoint and form a line. So it looks like really is a line, but the endpoint would be something that they're sharing. So in this case, you could use point C. So we're going to go ahead and name both rays. So here we're going to start with the following. Here you have, let's use point C pointing this way towards point A. So remember, C is going to be the point we're going to use for the first point for the ray. So it's going to be C followed by A, and don't forget the symbol. Okay, and the opposite one, that one could be this one right here. Okay, CB. Again, C is the endpoint, so we're going to use that same endpoint, and that one can be thought of. So you could use again C, and then pointing towards B, going this way now. So that would be the opposite of CA. So it'd be C, B, and then again show the arrow showing the endpoint being C. Okay, so that's opposite rays. Okay, so here's an example here, and we're going to start with the following. Name 3 line segments. So let's go back to what is a line segment. Line segment is it starts at some point, ends at some point. So we could use, say, point D, and we could stop at E. So if we could use point ED. Okay, make sure you don't include the little arrows. Okay, so we were talking about starts here, ends here. I could have used, say, DF. So starts at D, ends at F. That would be another segment. Okay, I could use, say, I don't know, EF. EF could be another example. So E, F, and then a line right there. Okay, so there's 3 right there. So that's what segments are. All right, now next one, a ray. Name 4 rays. So what's a ray? So let's go back here. Let me erase that. array starts at an endpoint, but then it goes on forever. So it doesn't stop at f, as an example. It goes on forever. So I could say d, and then it goes on forever. So d, and I'll use another point. So df. All I need is 2 points. So I'm going to use d, and then f. Remember that the point d, the end point is the one you're going to use first. So that would be d, and then I would indicate an arrow. Now you could also use DE. Okay, so I could have used from here to here, and then that goes on forever from here. So this would have been array right here, so I could also use DE as an example. Okay, now there's more examples here. It doesn't have to be that way. You could also switch it around. You can say use point F, I'm sorry, and then E, and then goes on beyond E. So I could have used FE. And then let's do one more. Let's use point, let's use E. We'll use E and D, and so indicating going this way. So we'll use E and D. E being the endpoint. Alright, moving on. We're going to go ahead and now look at which rays are opposite rays. Okay, so opposite rays share a point. So the one that shares a point between these 3 points would be letter E. So E would be my sharing point, that would be my endpoint. So I could indicate a ray going this way, and I can indicate a ray going this way. So if I'm going to go from pointing down this way towards my left side, I would use ED. So I would use ED, and I would use E going towards F, so I would use EF. So these two would be opposite rays. And I don't think there's another example here where you could use opposite rays. There's no other sharing of a point, so that one's not going to work. So that would be my only possible answer for the last one. Okay, now we're going to talk about postulates. Postulates are always true, no matter what. It's things, they're like definitions. We accept them to be true, and let's go through each one. So 1, through any 2 points is exactly, well, it's going to be exactly one line. Okay, so you have a line, and if there's 2 points, through any 2 points, so here's A and B, you draw it, and you can draw a line. I draw another point here and here, let's call it C and D. I can draw a straight line. So wherever there's 2 points, you can connect them and make a straight line. So that's postulate 1. 1, 2, if 2 lines intersect, they intersect at exactly 1 point. Okay, so if I draw 2 lines, I'm going to draw one line this way and another one that's going to intersect. Well, the intersection will create a point, and that's what that means on 1, 2. 1, 3, if 2 distinct planes intersect, they intersect in exactly one line. So if you look at this drawing here, you have 2 planes and they're intersecting. They're intersecting right here at this line. Okay, that intersection right there is going to be line ST. So we'll just go ahead and show you that it's talking about line ST. And then finally, postulate 1-4, through any 3 non-collinear points, there is exactly one plane. So let me go ahead and draw that out. So, and we've talked about this, that if you choose 3 points, okay, so non-collinear meaning they're not on the same line. So I choose this point here, and this point here. Well, that draws out a plane. It draws this triangle as a plane, but remember, planes go on forever. So this expands, this expands, this expands. Once you draw out and it turns into a flat surface, so if it's a flat surface, that's a plane, and 3 points that are not in a straight line, well, that turns into a plane. So it's a kind of logical thing. So if you have these points out there, here A, B, and C, that those are non-collinear, they're not in a straight line, therefore it forms one plane. Okay, so finally, this is the last part of this video, and here's our example. We have a cube, it's got a bunch of letters. We're going to go ahead and answer these questions. What is the intersection of plane CUE and plane EBT? So CUE, well, CUE is talking about this right here. So here's CUE. Okay, that's this one right here, CUE. And then they're also asking on plane EBT. Well, EBT is right here, so they're talking about this plane right here. And what is the intersection? Well, when there's two planes, the intersection has to be a line. So that line would happen to be right here. That would be the intersection. So that would be line EB. Or you can go the other way. You can call it BE. Are points C, A, and E coplanar? So let's go ahead and show those points here. So C, E, A, and T. So those are the points they're talking about. Is this coplanar? So what does coplanar mean? Coplanar is, does it form a plane? Is it possible that these lines can form a plane? So let's see, let's go ahead and connect these. And you're thinking, well, wait a minute, how can this form a plane? I mean, I can connect these two, but remember, let's connect the points themselves. So let's go ahead and go this way. So I'm going to connect this, go across. It's like I'm slicing this in half, or diagonally. And if you notice that this right here is a plane, and you can see that this is forming a plane. So that is this does work, and therefore this is a plane. So we're going to go ahead and say that these 4 points are considered coplanar. The answer is going to be a yes. Okay. All right. If you need to look back at this video again, please take your time. I know there's put pause on the video and look at it if you want to look at it one more time, because there's so much information. But that's 1.1. Section 1.1 has a lot of vocabulary, so please go over it if you need to. Make sure you understand it. I know it's a long video, but I'm going to go ahead and stop here, and we'll see you guys tomorrow. Make sure you do your summary. There's so much you can talk about in the summary, and so we'll see you tomorrow morning. Bye.